Welcome to the beginning of Chapter 11. Today we are going to discuss some basic formulas that we're going to be using at the beginning of Chapter 11, and then we'll do a separate video with a bunch of examples. I might do about one example of each in this video because just writing out the formulas is pretty simple. Right? I don't really have these by lesson numbers. I think this is lesson 1 and lesson 2, and I don't even think this is in our book, but I do want you to know it. All right, and then we'll kind of move forward from there. Remember, your homework for this stuff is all worksheets anyway, so I just have worksheets that relate to this stuff instead of doing book homework. All right, here we go. Dealing with circumference. We're dealing with arc length, which is different than arc measure. We learned about arc measure back in chapter 10. Area of a circle, area of a sector, so we'll define a sector for you, and then area of a segment. Once again, we will define segment for you. All right, so let's start with circumference. You guys probably already know this formula. You may have forgotten it, but circumference equals 2 pi r, where r stands for the radius. Okay. Now, sometimes people will do pi times diameter, because if you think about it, 2 times the radius is the diameter. So if I take the 2 and the r together and I make that into a d, we could do pi times d. But the rest of our formulas, we're going to be using r anyways. So I'm just going to stick with this one, 2 pi r. Okay. Now, I'm going to talk more about pi later on. A lot of times back in middle school or whatever, you were told you could use 3.14 for pi, or sometimes 22/7. Completely forget about those things. You're not going to be using 3.14. You're not going to be using 22/7. Those are approximations, and they can cause problems when we end up rounding, if we end up rounding. Okay? Let's jump down here to area of a circle, because this is another one you guys might already know. All right, so do you want to remember area of a circle? Okay, circumference was 2 pi r. It actually has the same exact things, just kind of a different way we list them. So area of a circle is, you want to remember, pi r squared. Pi r squared, okay? Now this means that you square the radius first and then you take care of the pi. If we wanted to multiply pi and r first, we'd put that in parentheses, and we don't have that here. So we square the radius first and then we multiply by pi. All right, now arc length. Okay, let's look at a picture over here. All right, so we learned earlier that an arc was part of a circle. So it's this thing over here. And we learned how to find the measure of that by using this angle. So if this angle was 80, then this arc measurement was 80. But we also learned that if we had different size circles, even though they might all be the measure of 80, they have different distances. Remember the whole roller skating example where everybody turned 180 degrees, but they traveled different distances because the circles were different sizes. So the length is actually the length from here to here. So all it is part of the circumference. Okay, the whole thing is the circumference. Remember, the circumference is the distance around a circle. It's like the perimeter of a circle. We use a special name when we're dealing with circles. We call it circumference. Okay, so this is part of that. So let's just think about that. So arc length equals part of circumference. Well, of in math, we know means multiply. Circumference. So part of the circumference. Well, what should we put here? Part. Well, what part is it? Is it a half? Is it a fourth? Is it a third? Is it 2/3? Well, it's going to be some kind of fraction. I may not have left myself enough room here, but it's going to be some kind of fraction. Well, how do I know what fraction? Well, all we do is we use the arc measure. Okay, let's say this is 80. Well, we know the whole thing, all the degrees, is 360. So we want 80 out of 360. And if we reduce that, we would get, in that case, 2/9. So it would be 2/9 of the circle. If this was 90, that's pretty easy. 90 out of 360 is 1/4 of the circle. So it's a fraction, and it's related to the arc measure, and we always put it over 360. 360 degrees. And then I'm going to write this as arc measure, because I didn't leave myself enough space to write it out long ways. And the arc measure is in degrees as well. So it's arc measure over 360 times 2 pi r. Let me zoom in a little bit to make sure you guys can see that really well. All right, so arc measure over 360 times 2 pi r. Like I said, we'll probably do one example of each on this video. Okay, so you're going to have to memorize this formula right here. Arc length equals arc measure over 360 times 2 pi r. Arc measure is in degrees, so the degree symbols are going to cancel out, so we don't really have to worry about that as we get to part of our label. Okay, let's talk about these last two. Area of a sector. Okay, so let me draw a sector for you. It kind of has the same idea as what we just did with arc length. So we got something like this. Okay, now a sector is all of this. It's kind of like a slice of pizza. Okay, the definition of a sector is part of a circle bordered by two radii and an arc. Okay, so here's radius number 1, radius number 2, and an arc, and that's the boundaries. And I want the area of this. We could also do something like this. We could make it kind of bigger. Maybe I got something like this. And then that way maybe I want this. Maybe somebody's really, really hungry, and so they want more pizza, and they eat like 2/3 of the pizza. Okay, well we still have bordered by two radii, radius number 1 right here, radius number 2 over here, and then a major arc, bordered by two radii and an arc. Okay, the formula is almost the exact same as this one up here, except that since we're dealing with area, we can't use 2 pi r, we have to use pi r squared. So the formula is almost the exact same. It's going to be arc measure over 360. I'm going to write it a little bit better this time. Area of a sector equals arc measure over 360 degrees times pi r squared. Okay, it's part of the area of a circle. Part of a circle. Okay, here's the area of a circle. Of means multiply. Part, we're dealing with a fraction. So what fraction? Well, it depends on the arc measure. All right, finally, area of a segment. Okay, now you might be thinking segment. Well, I thought a segment was part of a line. It doesn't make sense to have any area because we learned earlier that lines don't have any like depth or height or anything like that. They just have a length. So how do you find area if it's only got one dimension? Well, this is another one of those words in geometry that has multiple meanings. So let me show you what a segment is. So if I do the same type of thing I just did, where I draw something like this, but now I'm going to draw that chord in there as well. Okay? And I'm dealing with this right here. All right? So what in the world is a segment? It's part of a circle bordered by an arc and its chord. An arc and its chord. There's the arc, the curve, the chord is the segment. So how in the world do I find that? Well, look back at this one. It's kind of like that, right? Except that I don't include all of this stuff in here. I just kind of have, it's almost like the crust of the pizza. Okay, so I just have this kind of outer section right here. Except the crust is usually kind of curved too, so it's not a perfect example, but that's the idea. All right, so I do this area right here, which we just learned is this. And then what I don't want is this triangle. And we know how to find the area of a triangle. All right, so area of a segment equals sector area minus triangle area. Sector area minus triangle area. Let me write that out here in a little more detail. Arc measure over 360 degrees times pi r squared. Remember, that's what this formula here said. So arc measure over 360 times pi r squared minus triangle area, base times height divided by 2. Or every now and then we're going to learn about a different triangle area, right? An equilateral triangle area, and I'll introduce that to you in another video later on, but we might do that sometimes as well, and it'd be a slightly different formula right here. Okay? All right, so let's look at an example of each real quick. Just one example of each, and in the second video we'll do more examples. So let's say we have a circle, and we have an 8 right here. Let's find the circumference. Okay, so circumference equals, remember from our formula, it equals 2 pi r. So I'm going to take 2 times pi times 8. Now the order of multiplication does not matter, so I can do 2 times 8 is 16 pi. And let's come back over here real quick and let's change this and let's put feet. We're going to do a lot of actual labels in this chapter rather than units, so 8 feet. So my label is feet. It's a length, okay, not feet squared, that would be area. You can leave your answer just like that. You don't need to use your calculator at all. Now if you did use your calculator, all right, let me show you the difference between two things. Okay, so I've already got them typed in. I want you to look at this. Your calculator actually has, and I typed it in earlier up here too, but your calculator actually has a pi button, okay? And then here's the 3.14 approximation you probably learned about earlier. Look what happens if you actually type in 16 pi. It gives you this big long thing, and it keeps going and going and going and going and going. Let me show you real quick why. Here's pi. To get to pi, all right, it's sitting right here. So you hit second and then pi, all right? And I'm gonna hit enter. Pi is this big old long decimal. It's not just 3.14. It's 3.14, 159, a bunch of other decimals. It just keeps going and going and going. It never repeats and it never ends, right? So if I take 16 times this big massive decimal, it gives me this. And then I tell you to round things to 2 decimal places, but we could choose to round it to 3 or 4 or however many we wanted to. But if you rounded this to 2 decimals, you would put 50.27. Well, if I did 16 times 3.14, I'd get 50.24. You see how far off you are? You're 0.03, really 0.025 and a bunch of other decimals off. But if we round, we're 0.03. Now, is 0.03 feet a lot? No, not really. What about 0.03 miles? Well, yeah, then we're starting to talk about a significant distance. All right, so I don't want you using 3.14 at all. If you use 3.14, I'm going to mark it wrong. I don't care if the book tells you to use 3.14, don't use it. All right? So you can leave your answer like this, or you can write it as 50.27 if I tell you to round it. If I don't tell you, I want you just leaving it exact. If I say exact, you absolutely have to leave it like this. All right, let's come back to the same one and let's find the area. So area equals pi r squared. Okay, well, what is 8 squared? 8 squared is 64 pi. Label for area, feet squared. That's it. Stop. Don't do anything else. Nice thing about this is you shouldn't even need to use your calculator. But let me show you again the difference. If you choose to type in 64 pi versus 64 times 3.14. Big difference. All right. Now we're talking, it's a whole 0.1. Okay. All right. If I ask you to round it off, put 201.06. Do not put 200.96. That will never be correct in my classroom. Okay. Shouldn't be correct in any classroom ever, to be honest with you, because it's not. All right. 3.14 is an approximation, and when you round, all right, when you round this off and then you use it again, we've talked about this many times, your answer becomes more and more inaccurate the more times you round. Okay. So we're not going to be rounding early in the problem ever. All right. Okay, let's look at one example of arc length and area of a sector and area of a segment, and then we'll stop this video and we'll start up on the next one. Okay, so let's come over here. All right, so what do we got? Circle. Let's say that this angle is 80 degrees right here, and that this is 10 meters. And I want you to find the length of arc AB. Okay, that's what we're going to be working on. All right, let's look back at our formula real quick. Arc length equals arc measure over 360 times 2 pi r. Arc measure over 360 times 2 pi r. So let's apply that here. Arc measure over 360, they both have degrees on them, times 2 pi r, which I'm going to put over 1 to make this easier. Now we're going to do some reducing. You can reduce and then multiply. You can multiply and then reduce. I don't really care. I think it's a whole lot easier to reduce first. So first off, the degree labels are going to cancel off, so I don't have to worry about them. And these zeros can cancel off. So taking off a 0 is like dividing by 10. Now I might reduce a little farther with the 8 and the 36. They're both divisible by 4, so that can become a 2 and this can become a 9. Now we multiply straight across. Do not cross multiply. I've seen that way too many times. That's what you do when you have an equals sign in here. This is not an equal sign, it's a times sign. So multiply straight across. 2 times 2 is 4. 4 times 10 is 40. Don't forget pi. So this equals 40 pi over 9 times 1 is 9. Double check at the end, can you reduce this at all? 40 is divisible by 4 and 10 and 8 and 5 and 2. 9 is only divisible by 3. So they aren't divisible by the same thing. We're done, except for our label. Come back here. Meters is our label. Arc length is a distance. So we put meters. That's it. It's not squared or anything like that. No need to use your calculator. Unless you can't do 2 times 2 times 10 or something like that. Or if you can't reduce the 8 and 36. Okay, we're not going to type this into our calculator. Unless I specifically ask you to. And if I do, it's really easy. 40 pi. If you don't put times in there, your calculator knows that you mean times, divided by 9. Enter. 13.96. Okay? But I don't want you doing that for the most part. All right, let's do a sector area. Okay, 110 degrees. Let's do this as 12 centimeters, and we're dealing with all of this area. Okay, so look at our formula one more time real quick. Arc measure over 360 times pi r squared. Arc measure over 360 times pi r squared. All right, so here we go. Arc measure, 110 degrees over 360 degrees times pi 12 squared, which I'm going to put over 1. Okay, let's do a little reducing. Degrees cancel, zeros cancel, 11 and 36 can't reduce at all. 12 squared, I can write as 144. Now you could reduce here. Now, sometimes people get confused by doing that because they get it confused with the cross multiplying thing, and if that confuses you at all, just multiply, reduce at the end. That's what I'm going to do real fast. 11 times 144. Now you might need your calculator for that one. So 11 times 144 is 1,584. Don't forget pi over 36 times 1 is 36. Now this we can definitely reduce. So 1584, I'm just going to try dividing it by 36 and see what happens. Well, it divides nicely. 44 pi. Okay, if you aren't sure if it would divide perfectly, you could divide by 4 to start with and then keep going. All right, I'm going to kind of show you how you can do this a separate way. So we had that 110 over 360 times pi 12 squared over 1. All right, so we cancel the zeros. This became 144. If you notice that 36 and 144 can reduce, they're actually both divisible by 36. If you don't notice that, let's just start with 9, see what happens. So we divide by 9, we get 4. We divide by 9, we get 16. We divide by 4, we get 1. We divide by 4, we get 4. 11 times 4 is 44. Don't forget pi. And then in the denominator, 1 times 1 is 1. I can put it over 1, but I don't really need it. 44 pi. See how we get the same answer? Now label for area, remember, is squared, and this was centimeters. So I'm going to put centimeters squared, and there's my answer. All right, one more example. We're going to do segment area. So I'm going to keep this one kind of simple. Here's my circle. I'm going to make this a 90-degree angle. I'm going to draw this chord here. Okay, and we're going to say that this is 6 feet. We're just dealing with this right here. Okay, so remember our formula one last time. Look at our formulas. Sector area minus triangle area. Sector area, remember, is this formula. So sector area minus triangle area. Okay, so let's take a look at that. Sector area. Arc measure, 90 over 360. I'm not even going to put degrees. We know they cancel off by now. Times pi 6 squared, which is over 1 to make it easier, minus my triangle area, which is base 6 times height over 2. Well, what in the world is the height? what is this height right here? Hopefully you realize really quick it's a radius. And this is a radius. And the radius of a circle never changes, so it has to be 6 as well. Alright, let's do some reducing. Cancel the zeros, it's the same as dividing by 10. 9 and 36, so 1 and a 4. 6 squared is 36. Okay, let's multiply. 1 times 36. Don't keep multiplying, there's a minus sign here, so just stop. 1 times 36 is 36. Don't forget pi. Over 4 times 1 is 4. 6 times 6 is 36 over 2. 36 pi over 4, that reduces to 9 pi. Minus 36 over 2 is 18. My label is feet squared. Now, this is how we're going to kind of write our answer, so pay attention here. This right now kind of looks like the feet squared is only with the 18, and the 9 pi doesn't really have a label. So instead of writing 9 pi feet squared minus 18 feet squared, what we're going to do is we're going to put this in parentheses to say all of this is the number and the feet squared goes with all of it. Okay, so that's how we're going to write that answer. 9 pi minus 18 feet squared. Now once again, we can type it into a calculator if we really want to and get a decimal, but most of the time I'm going to tell you just leave your answer like this. Okay, so that's the first part of chapter 11. All right, so you got to know these formulas. I'm going to put them up here one more time, zoom out just a tiny bit so you can kind of see them all at the same time. But you need to know these 5 formulas. Okay, right there. All right, make sure you know them. That covers the first, I think, 2 lessons in chapter 11. I'm going to come back with another video and do some more, a few more examples. Some will be a little more complicated. Okay?